So, as always, the code for this question will be in the description, but if you want the explanation, you can continue watching this video. So, this is a pretty tricky question, and the other point you need to remember is, it is tricky, but at the end, you can get the answer. The code is actually really simple for this one. Just the first thing is understanding what the question actually is, what they're asking you. The second is what the intuition is for this code, for the algorithm basically. So let's start with the question first. Now, they said that in the input they'll basically give you a length, the n value n, which will be the length of the binary string, which means that let's take for example a binary string such as 10110, some string like this one. They'll be giving you this thing, which means the length of this is 5. This is, for example, what they'll give you. Now, what should we output? We should output another binary string of length n plus 1, which means 1, 2, 3, 4, 5, 6, 6. Okay, so what is this number? How will we get this binary digit of length n plus 1? This is the output we're supposed to give. Now to get this thing, we'll backtrack from here, okay? So in order to get this thing, what you basically have to do is take another binary string, okay? I'll tell you. In order to get this binary string, first select some binary string L, which is, let's take this. This is L. This is the binary string L. Now, if you XOR this S, this is the S binary string and this is the L binary string. If you XOR this values, every single one of them, what you'll see is you'll get this, right? And this is a palindrome. The left side is equal to the right side. This is a palindrome. So which means that for this value of L, if we XOR it with this, we'll get a palindrome number. Now, in this L, we have two ones. The number of ones in this binary string is 2. Which basically means that in this case, it will be 0, 1, 2, 3, 4, 5, right? There are two ones in this one, which means you should return 1 here. So basically what this means is, there are multiple combinations, right? L is not just this. You can also write L as this. You can also write L as 1, 0, 1, 1, 0, and you'll get 0, 0, 0, 0, 0. In this case, the value of number of ones is 3. It's 3 in this case. So, it will be 1 here too. So, basically, you need to find this value, which is that basically the number of ones in all the possible combinations of L, for which if we XOR with S, we'll get a palindrome. The result will be a palindrome. So whatever possible result, for example, there is another L case such that this will become a palindrome if we XOR it with this, and the number of ones is 1, so it will become 1. But there is no possibility where it's for 0 it will become a palindrome for all zeros, so it will be 0. And for this one, let's say it won't be, and for this one it will be. So this, which means that in this particular combination of L's, like the L string, the number of ones in that particular combination, if it is 1, then yes, in any particular combination of that L where the number of ones is 1, if we XOR it with this, we'll get the resulting string as a palindrome. You understand this thing, right? So with this thing, now we understood that we need to find the number of ones. This is basically the number of ones. Number of 1 is 1, the number of 1 is 2, 3, 4, 5, and 0. So now this is the question. The question is basically the number of the count of the ones which will be derived from L, which means that for which if we XOR with L, we'll get a palindrome. That's the question. Okay, it's a bit confusing, I know. Now, how do we approach this thing? See, the thing is, all of this is complicated, but whenever a question gets complicated, what you're supposed to do is break it down to its bare bone essentials. This is the question which is given in the Codeforces editorial, but that's not the question we're actually supposed to be finding. Or in a way, what I'm trying to say is, if you boil it down, get some essential element, which is the actual question, which will solve this one. We just get down to what that is. Okay, In order for that, let's look at this thing properly. Okay, so now take a look at this thing carefully. I have another string. This is much more easier to explain for me. No, it's not that this is a particular combination which is easier. It's that I want to take a string which is longer so that to see just how easy it is. You think it is difficult to find it for this one, but it's actually really easy. See, I'll tell you one thing. They're not asking, the first point is, they're not asking us to find all the combinations of L. First thing, they're not asking us to do that. They're asking us the number of ones, the number of ones in all of the possible combinations of L, for which the L when XORed with S will give the palindrome. So they are asking us the count of ones, not the L, the possibilities of L itself. You can say, oh, it's 2 power n. No, it's not 2 power n. Not because they did not ask you all the possibilities. They just asked you how many ones will all of the possibilities have if you combine all of them. That can be done in n time, first of all. Okay. So see how this thing goes. XOR basically means one thing, right? If you draw the XOR truth table, so if you look at this XOR truth table, what you'll get is, as long as if both the elements are 0 or both the elements are 1s, the result will always be a 1, right? This is not a big of a deal, but I just wrote down this table for reference purposes. Now we'll look at this thing. So you look at this string, okay? Now what did they ask us? First things first, this should be a palindrome. This should become a palindrome. That's the result, right? And what made this thing a palindrome? XORing it with L. So from that L we can take the number of ones and we can input it in that array. So for that we need the first step. If you look at these 3 points, the first point is this should become a palindrome first things first. That's the first point. This should become a palindrome. What does a palindrome basically mean? This element will be equal to this. This element will be equal to this element. This will be equal to this, right? That is what a palindrome is. Notice this thing. These two are equal already. So they already match the property of a palindrome. These two are similarly equal. They also match the property of a palindrome. But these two elements are different. So see, the thing is, if you look at this thing carefully, what you'll realize is, if you think at this thing properly, at this point you might have got an idea, and I suggest you to pause this video and think about this thing properly yourself. Yeah, so as always, we all know that we are not going to do that. So you can listen to this video, but I suggest you to think on your own, okay? I'll tell you one thing. The thing is, if these elements are palindromes, then there are multiple possible combinations of L, right? So in L, it could be that we can just take, for example, L is this value, we take it as dashes. If 1 and 1 were here, if we had 1s in both these places, to XOR to 0, right? After they become 0, they still satisfy the palindrome condition, which is that this element should be equal to this element. So they're still equal. So if there are zeros, then it will become 1s. So regardless of whether it is 1s or zeros, the condition satisfies. It will become 1, 1. But both of them should be the same thing. So is it 0 or 2 ones? 2 ones. See, we're getting a count now. We're getting the count of ones. This is the L, by the way, if you're wondering. So now in this case, you could add 2 ones here. Both here and here, you could add 2 ones. 1 and 1. But you must add 2 ones. Either 2 or 0, that's it, right? So now we're getting a count somewhere. Same goes for this. These two are equal. So you can add technically 2 ones here. You can. You can't add 1 and 0 here. So that's not how it goes. If that is the case, then what will happen? It will become 0. This will become 1. It does not satisfy the palindrome condition. So in order for that, it should be 1 here. Both 1s or both 0s. That's it. Now look at this thing. In this one, in order to make this a palindrome, either I'll write it down in separate condition here. This should be 1 and 0. Yeah, 1 and 0. This should be 0 and 1. So if you look at this thing careful, this condition basically means that if the element does not satisfy palindrome condition, what it basically means is that you only have one. In both of these combinations, there are multiple possibilities, right? So I'm exploring these possibilities. But in both the possibilities, you don't need the possibilities themselves. You just need the count of ones. And in both of them, the count of 1 is 1. If you look at this thing like a mirror, the count is 1. Count of 1 is 1. So what did we realize from this thing? If this elements, if you take a pointers and we look at the elements, if they satisfy the palindrome condition, that means this positions of L could have 2 ones, could contribute to 2 ones. Similarly goes for this one. But for if in any condition, if both the element does not satisfy the palindrome condition, there can only be 1 1. And there must be 1 1. That's the important case here. There must be 1 1 at any cost for this thing to become a palindrome, for this entire string to become a palindrome. Till now we are checking the palindrome condition for the elements, but no, this string should become a palindrome. Doesn't matter if you change these or not, because they're already satisfying it, but these must be changed at any cost in order for this string to become a palindrome. So basically means that doesn't matter whether you add 1 over here or 0 over here, it doesn't matter, but these two, any of these two must be added. You can't add a 0 0 here in L, in this dashes you have. So basically means that, oh, look at this thing. We still want, if you came this far and you didn't pause in the first time, at least pause now. As always, you're not going to pause again. I know that thing, but I will suggest you to pause it to get the intuition on your own. But see, we are already 90% there, okay, so it doesn't matter. But I'll tell you one thing. If you put 2 pointers, what you can do is you can take the count of number of elements that satisfy the palindrome condition, which means that you can take a pair. The number of pair of elements that satisfy the palindrome condition, you can take the count. And for the number of ones that don't satisfy the palindrome condition, you can take the pair as a count. Now, look at this thing carefully. You have this and this. Now, what are the possible combinations that can come from this? Just these two. Okay. Let's take that 1 and 0 as a thing. Okay. Let's take. There are 0 and 1 also for this one, for this case, but let's take. There are multiple possibilities, right? There can be 1, 0, 1, 0, 0, 1. There can also be 0, 1, 1, 0, 1, 0. It can also be 0, 0, 1, 0, 0, 0. Right. There are multiple combinations if you look at it. This basically means that the count of the same elements, palindrome satisfying, which means that let's take the variable as yes here, temporary variable as yes, satisfying is 2 and no is 1. So since there are 2 elements, there are 4 possible combinations here, which means that we'll have 2 into the number of elements, which means that 2 into whatever the count is, possibilities, what is it? 2. Basically means that there are 2 possible ones, right? Because let me explain this thing to you. Okay, the no one I'll explain later, the yes one. First case, first things first, we need the count of number of ones, right? We can take a set. You can take a storage value where you need to store all these values, because the number of ones is that's the answer. We need that thing first. So 2 ones is for this one, which this number signifies the fact that there must be 2 ones at any point. It's not that there can be only 1 1. No, there must be 2 or nothing, right? The first combination that we look at is 2 ones for both of them, which means that in this case, for this 2 elements and these 2 elements, 1 is possible. So we multiply it by 2. The second condition we look at is, this is for the first number of ones count, which is 4. We'll get 4 ones. So hold on for this thing. The second condition is only 1 into 2. Which means that only one of the possible ones have 1. Like 2 ones. Either this or this one. For that 1 into 2, which is 2. Or none. You take 0. Which means that 0 of them have 1s. Which is 0. These are the possible combinations. If you keep this thing, if you forget about this thing, these are the possible combinations of 1. What you're simply supposed to do to this answer is add the number of pair of elements that do not satisfy the palindrome condition, which is 1. Basically with this you will get 4 plus 1 5, 2 plus 1 3, 0 plus 1 is 1. So basically the resultant, now that you have these numbers, the resultant result you will get, resultant result. Basically what you will get from this thing is the answer that we require is an n plus 1 array, right? So it will have 1 2 3 4 5 6, 1 2 3 4 5 6 7. So basically it will be like 0 1 2 3 4 5. This will be the array you will return, because on position 1 you will have 1, on position 3 you will have 1, on position 5 you will have 1. That's basically the intuition for this thing. If this thing is even, what if it is odd? Now there are 7 elements here. Don't panic, it's easy actually. In the code, even in the code, there's a small thing. The thing is, if it is odd, everything up to this point is the same, except for that over here in L you have another dash, right? Everything is same. 531 is still valid for this one, but this element you don't need to check the palindrome condition for this one. You don't need to check does this satisfy, because 1 is equals to 1 all the time. So it can be either 1 or 0, which basically means that you simply need to add another element to this one, which is 5 plus 1 6, 3 plus 1 4, 1 plus 1 2, which means that now this array will be updated to, this will be the returning array. We simply have to add 1 to each and every, before you append this 5 we'll append this 5 and also append the 5 plus 1 6, because there are 2 possible combinations for this one. This is the basic intuition. If you look at this thing, the question was hard in your mind, but once you've broken it down and you look at what you actually needed, you got the answer pretty quickly. The intuition was pretty easy. It's a simple thing. You have n, this is an n O of n time complexity solution. So yeah, that's basically it for the intuition. Now I'll get to the code. Yeah, so as you can see here, the code is basically the same thing. First will be given an input n, which is the length, and then will be given the actual integer, which the actual binary value. And then what we'll do is, first things first, for convenience sake, I've taken this thing as an array so that I can iterate to it much better. We can do another way too. And then the L and R pointers, basically the pointers in which we have to check whether the pairs are palindrome satisfying conditions or not. And the same thing, if it satisfies, it's the same thing. And if they don't satisfy, that means that the elements are different and they don't satisfy the condition of palindrome. Now we'll take the possibility, we'll take a thing called set possibilities, which will store the possibilities, which means that like the possible combinations. In the previous example it was 5, 3, 1, right? So it will be stored in this possibility set. And then we'll iterate through the while loop, where we'll check whether if these two are equal, then it will be same, and if it is not, then different. And then we'll stop the point, we'll stop it when L is not less than or less than R. That's the point basically. So after that thing, if you look at this thing, it's the same basically. From here, the thing is that the condition I told you, if it is even, it's well and good. That's the same thing. If it is even, the number of binary values, if it is even, the length is, if the length of the basic string is even, that means that you just have to add 2 into same plus difference. That's what I told you, right? 2 is basically here the number, which means that 2 is the number of ones we need to have, which is at most 2 for the same value. If they are same, then you can either have 2 or either have 0, right? Now the thing is plus different, because you need to manually add different, right? Now we'll decrease same by 1. we'll keep decrementing it again till same is less than 0. So like that, what we'll do is we'll get all the possible combinations, which is for 4, for 2 and for 0, right? That's what happened then. No, for I think it was for 4 and for 2 and for 0. For that we had to get all the possible combinations. So same, we'll keep decreasing it and we'll keep adding it to the possibilities set. Now if it is different, if n is odd, then what we'll do is we'll add this 2 into same plus different, and we'll also add another thing into the same possibility set, which is this plus 1. That's the basic intuition. Now after that we have to take an array answer string and we have to take it from range n plus 1. And then what we'll do is at the end we'll append if I is in possibilities, which means that if that number of what is possibilities basically set. It is a set of the number of ones, right? And in the array, if you take it, for example, if you take this thing as I don't think I can change it. Yeah, code view is read only. So if you look at this thing, if it is 1, if I is for example 1 in that case, that means there are number of, in that particular answer array, the number of elements in L array could be 1. The number of count of 1 could be 1, right? So yeah, if it is 1, then it should be in possibilities. That means if it is in possibilities, then answer will be plus equals to 1, else it will be 0. That's it, and we'll print the answer. So basically an easy question if you understand this thing properly. So yeah, that's it. Thank you.